Alright, when we left off on the last video, we were trying to find out what the end behaviors of a rational would look like if the higher degree was on top. So 15x to the power of 5 minus 60x cubed minus 30x squared plus 45x plus 30, and the lower degree was in the denominator, 5x squared plus 10x minus 40, as you can see right here. So it turned out that in the middle, we had to kind of see where these zeros would be, and we had a hole at, as you can see from the equation, the top and bottom both have an x minus 2. So if I go to 2 and I trace where it is, if I go exactly to 2, you'll see all the 2.3 has a value, 2.1 has a value. All of a sudden you get 2 comma undefined. So you can see right there, as soon as you get down to 2, it's undefined. Okay, so there's a hole there. On the top, you also have an x minus 1, so that means at x is 1, you have a 0, 1 comma 0. You also have a x plus 1, you actually have 3 of them. So at negative 1, you also have a 0 there. But on the bottom, you have an x plus 4, which means at negative 4, you have yourself an asymptote, as you can see there. But the end behaviors are the interesting thing. If you actually do the division, you end up with this p of x here, and it shows what the end behavior will do. It actually follows this asymptote, the 3x cubed minus 6x squared plus 24x minus 102. So that's a little recap. What happens now if we put the 5x squared plus 10x minus 40 on the top, and the 15x to the 5 minus 60x cubed minus 30x squared plus 45x plus 30 on the bottom? So instead of f of x over h of x, we have h of x over f of x. So let's check out this new graph and see what it looks like. Let's get it a little bit more visible to us. Alright, see how that is. Alright, so as you can see, we have two asymptotes. I don't know why it graphed the asymptote here. Let's see if I can find one where it doesn't actually graph the asymptote. There we go. So as you can see, we have an asymptote right at negative 1, and we have another asymptote at positive 1, because our equation has x plus 1 on the bottom and x minus 1 at the bottom. You also have a 0. If you get in real tight, you're going to have a 0 at negative 4. So I'm going to go find that and trace along there. At negative 4, you get negative 4 comma 0. And you'll have another 0 at, at positive 2, you do not have a 0. You actually have a hole. So I'm going to trace all the way to positive 2 and see how the points kind of change. But as soon as you hit 0, boom, undefined. There's a hole right there. Right, so just before you're at like 0.062, you go up, undefined, now it's at 0.08. So there's that one little spot where it's undefined. So that would be a hole. You'd have to draw a little hole at that spot if you were to graph this. Okay, but what we're really concerned about is the end behavior. What happens at the end? Well, we're dividing 5x, a quadratic by a fifth degree polynomial. So I did the division over here. And if you look down here, a quadratic divided by 50, well, 5x squared divided by 15x to the 5, right here, 5x squared divided by 15x to the 5, well, 5x squared is small, the x squared is smaller than x to the 5. You can't do it at all, so it's just 0. Right, so you have 0, and then when you multiply across, 0 times all this just becomes 0x squared plus 0x plus 0, and your remainder is your original divisor, or dividend. I always mix those two things up. Alright, so that's your remainder. Well, then when you write your equation in our new form, we just get 0 plus itself. Well, that seems counterproductive, but it's not really counterproductive because it follows our rule, where this 0 is our asymptote, because that's what it's going to approach when you get a really, really big number for x, and this is going to only make any difference whatsoever when x is small. But when x is large, as you see, this x squared will go off to a very big number, but this x to the 5 will be a much bigger number and the bigger x is, the more this tends towards 0. Okay, so now you look and you see there is one more little thing to look at. If you put in a positive big number, this is going to be a positive times 5, which is positive, so the top will be positive, and x to the 5 will be positive, and 15 is positive, so you're going to get a positive. If you throw in a negative number, well, because this is an even degree, you're going to get a positive. 5 is always positive. X to the 5 will actually be negative if you throw a negative large number in there, and 15 is positive. So this overall will be a positive divided by a negative, so this will end up being a negative. So on the left-hand side, it's actually 0 plus a negative small number. So it's actually a little bit under 0. All right, so let's go confirm that with our graph. And sure enough, over here, if you look, I'm going to plug in z of x is equal to 0, so that's the asymptote right at 0. And as you can see, this is all just a little bit more than 0, see 0.001. If I go to the left-hand side, all those values are, well, it just says 0, but they're actually a little bit less than 0. Okay, they're getting closer and closer to 0 there. But they're a tiny bit less than 0. So this thing actually goes underneath and then comes back up to it. See here, you can see it's negative 0.001. So it didn't go underneath by very much. And then it came back up to it. So it does go just a little bit underneath. Alright, so that is what happens when you have a smaller degree on the top. And I'll do another video for the next part.